Up to this point, we've been talking mostly about retrieving data. I've been able to do all the select statements and filter out with where clauses and do projections with all the different fields and aggregates and whatnot. So let's shift a little bit up to updates. There's a couple of types of updates. We can add new data. We can manipulate data that's already there by updating it, or we can remove data. So those are the three update operations, right? And together, the select, the create, the insert, the update, and the delete make up the 4 CRUD operations that's all we really need, right, to manipulate and manage data. So let's first look at insert. So insert, like the name suggests, is so that we can add data to our database. It has a couple of different syntheses, depending on what it is that you're trying to do. The simplest of which is you want to insert into a table, and you provide the values, right? And that's it, right? That's the simplest syntax. Now, this insert is going back to the declaration of the table to try to make sense out of the data that you're giving it, right? Because here you're not telling it, all these values, which fields do they match, right? We're not being told. So what it does is that it goes back to the original declaration of the table. It says, I see that the first field is ID, the second field is username, the third field is password. So that's how it makes sense that those 3 fields, value 1, value 2, and value 3, right, map to those 3 fields. Make sense? Okay. Instead, you can use a more, yes?
What if the ID is an auto-increment?
You can provide null. Yeah, and so it says, well, you figure it out, right? And it'll auto-increment it. Yep. So here we have another syntax where we are explicitly telling it which columns do we want, right? Because the first one has also limitations that, maybe have like dozens of fields, right? And I only really want to, most of them are default values, right? And I don't really need to provide values for them. And I only really need to provide values for 2 or 3. And when I declare the table, those 2 fields are way at the bottom of the declaration, right? So what do I do with all these fields that are in front of it, right? It's a nuisance, right? That I would need to provide nulls for them or actual values for them. So perhaps a better alternative is to have where you declare the actual columns, right, and say, okay, well, for this column I want this value, for that column I want this value, and so on and so forth. So first a list of columns, and then the list of values, and they map one to each other. So here allows you to only work with a subset of columns, right, if you don't want to provide values for all the columns. Here's a really simple example of inserting into the persons, Boone, Daniel, and the address, and the city. And it adds it at the bottom. One thing to remember here is that even though here we are displaying it graphically as having a particular order, that the records are incrementally being added at the end of some subset of rows, in actuality, they should instead be thought of as a set instead of an array. Right? A set doesn't guarantee any particular ordering, right? And you should never assume that the data has any particular ordering. Okay? We would only display it in a particular order only for our convenience. We would sort by last name, or we would sort by city, or whatever, right? Only for our convenient for our frontal cortex. For inserting for specific columns, we could just decide that we only want to provide data for the first 3 fields, right, and leave all the other ones blank, right? And that would only work if address and city allowed you to have not null, right? If instead they were declared, excuse me, if they would be declared as not null, then this would not work, right? The database would bark, right, and would complain that it does not have values for those fields. Just to remember that the first set is the columns, and the second set is the values that we should consider them to be mapped 1-to-1. Okay. Also, any values that you do not provide, the database will choose a default value for you. You can provide the default value yourself. Subqueries. You can also declare the input into an insert statement as a select. So here's a select is retrieving data from one table, and maybe even joining two different tables and retrieving certain fields, and that can be the input into the insert of another table. This allows you to do all sorts of things, right? Where you can do a separate table that is a calculated value of some of these other two tables, right? Like a cross multiply or some concatenation or some filtering of these two tables joined together into maybe like a report, right? That would come up with or maybe a copy, or maybe like an archiving. You want to be able to archive data that from certain tables and archive it into some other tables for storage and whatnot. Okay, so here's an example of creating an alumni table where presumably what we'd like to do is take a look at all the students that we have currently and only choose a subset of those students who have already graduated. The ones who have been around at least for the last couple 4 years, right? Then presumably they graduated. Now they're alumni. We can copy them over to the alumni table, right? So here we're creating a alumni table, and we are copying from the student table and the department table. Notice that the alumni wants information about the major where they graduated, the graduation year, the student name. So we need to go to two different tables, but to the student table and the department table. Join these two tables, and when they match, then only retrieve those students that have a graduation year that is smaller than perhaps this current year, right? Maybe -4 or something, whatever criteria you want, and then copy them over into the alumni table. Here's another example that retrieving students that are in the same major with a particular graduation year of a particular student. Okay. So here, again, we have a second select statement that is calculating this, right? And then copying it over into this student table. Okay.